Hi guys, this is Terry here. I'm going to be going through the solutions to the January 2025 CSEC Maths Paper 2, right? But before I start, I just want to let you guys know that my exam preparation for CSEC Chemistry, CSEC Physics, and CSEC Add Maths, right, is in progress. And those of you interested, you can WhatsApp me, right? Just to let you know that this preparation is about 4 months, right? And just to note that several of my students placed on a merit list this year, right? One student placed 4th in CSEC chemistry, right, in the 2024 exams. And another student, she placed 9th in CSEC maths, all right? So start with this question here, right? Using a calculator or otherwise determine the exact value, right? So what I normally tell students to do, use a calculator, right? Forget about the otherwise, right? So we want to work out, the only thing that we need to know here is that this off means to multiply, right? And we can enter that information directly into our calculator. So we can put 2 over 3 multiplied by open brackets, 1 over 8 plus 5 over 12. All right, sorry, 5 over 12 divided by 1 over 9, right? Close brackets, and we're going to get this, right? So they said, giving your answer in exact form. So you can give your answer as 217 over 12, right? Or you could have written it as an improper fraction as well if you wanted, right? So this is A part 1. A part 2, we want to work this out, but you want to give your answer in standard form. So for this one here, we're going to use a calculator to do the calculation itself. So that is 314.2 minus, right? I'm going to use an open bracket here, right? And that's going to be 26082, yeah, divided by 52164. Close brackets, and we're going to get this, right? 313.7, right? So this is 313.7, right? But the thing is, they want the answer in standard form. So what we're going to do, we're going to shift the decimal point to the left. So we're going to go 1, 2. We're going to stop there. And if we want to write the answer in standard form, it is going to be, so when you move the decimal point, it became 3.137 multiplied by 10 to the power, right? You move 2 places to the left. So this is going to be 2, right? So that's my answer in standard form. Next part here. Jim packed several cases of fruit juice for sale, right? So we have cases of fruit juice, right? Each case contains 24 boxes of juice, right? And we have 3 different varieties, apple, orange, and pineapple. So the ratio is 2 to 5 to 1. So we have 2 to 5 to 1, right? So let me just write apple, oranges, and pineapple, right? And right, so each case has 24 boxes, right? Each case has 24 boxes. So that's our total that we're playing with here, right? Each case, right? That's what I said here. And then now they want you to figure out how many how many boxes of pineapple juice do we have in each case? So because we have a ratio 2 to 5 to 1, right? We have a total of 2 plus 5 plus 1, right? That's 5 and 2, 7 and 1, 8. So what we have here is 8 equal parts, right? So if you want to work out for pineapple, which is P, right? Pineapple in this case here, we have 1 part, right, out of 8, and you're multiplying that by the total number of boxes of juice here, which is 24. So 1 over 8 by 24 is going to give me 3, right? So therefore, we expect to have 3 boxes of pineapple juice, right? Now, this second part here, right? They said the profit gain from all the boxes of pineapple juice is this figure here, right? So they gave us the profit gained, right? And they're telling us that each box of pineapple juice is sold for $3.34. And we want to show that the cost price is $2.35. Now, I've read this question, but there's a problem with this question here, right? I know some students would have used this somewhere in their calculation, but the problem is you have to work the problem without using the 235, right? So there is something missing in the question because it's speaking about boxes of pineapple juice. So remember each, in the question I said each case, right, has 24 boxes, right? But you're packing several cases. And nowhere in the question did they tell us how many cases did we pack, right? So there's a piece of information that is missing here in order for me to prove this, right? So there's a problem with this question, right? And if I can't work this out here, I can't work out the percentage profit, right? But just for your knowledge, percentage profit is simply whatever the profit is, right? So your profit divided by your cost price multiplied by 100, right? But there's something wrong with this question here. Something is missing, right? Let's move on to question 2. So we have x squared minus 49, and we want to factorize this, right? So this is the difference of 2 squares. So this is actually x squared minus 7 squared, right? So if you want to complete the square here, sorry, not complete the square. If you want to factorize the difference of 2 squares, it'll be x plus 7, right? Multiplied by x minus 7, right? That's what we're going to get here. For the second one, we have a quadratic to factorize. So we have x squared plus 2x minus 35. Right? And we want to factorize this. So we're going to have 2 brackets. If you want to get x squared, we'll put an x here, put an x here. 35, let's try 7 and 5, sorry. Right? So if you want to get negative 35, but you want to get plus 2x, you should put a plus here and put a minus here, right? So 7 by negative 5 will give me negative 35, 7x minus 5x. So that's the answer when we factorize this, right? Next part here, we want to simplify this expression. So we have x squared minus 49. What students needed to recognize here is that we're going to use the information that we have from above in order to help us with this, right? So x squared minus 49, when we factorize that, we had gotten x plus 7, x minus 7, right? And when we factorize this, we had gotten x plus 7, x minus 5. So what's going to happen here is this will cancel with this, and you will end up with x minus 7 all over x minus 5, right? So that's our simplified version here. Next part, we want to rearrange this formula to make m the subject of the formula. So we have s is equal to k minus m squared, right? Carry the minus m squared to the left. So this will become just positive m squared on the left here. This will be k. Bring this s on the right side. So this is k minus s. And therefore, m is simply going to be the square root of k minus s. All right. Next part here. So we have Lisa has $56 to buy no more than 70 red balloons and green balloons for a party. She buys more green balloons and red balloons, but must buy at least 15 red balloons. Each red balloon costs 75 cents and each green balloon costs 50 cents. X and Y represents, so X is red and Y is green. So you need to have that in your mind there. X is red and Y is green, right? X and Y represent the number of red balloons and the number of green balloons. Write 2 inequalities in X other than X is greater than or equal to 0 to represent the information. So let's start with the $56, right? That's the amount of money she has to spend. So therefore, if I were to purchase X balloons, right, and the cost for the X balloons here is 75 cents, we can say that that cost would be 0.75, right, multiplied by X, right? The cost for the green balloons, let's say we purchase Y of them, right? The cost is 50 cents. So this is going to be 0.50, right? And the total cost for those green balloons will be 0.50 by Y. Now that total cost here, when I add up these two numbers here, I cannot exceed $56. So therefore, this has to be less than or equal to 56. So this is one possible inequality here, right? They also said that the total by a total number of no more than 70. So if it's no more than 70, it means that when I add up the red balloons plus the green balloons, right, I cannot exceed 70, right? No more than 70. So we can put less than or equal to 70. Can't exceed that, right? So that's a second inequality that we could get. In addition, they gave us some other information here as well. They said she buys more green balloons than red balloons, right? So more green than red. So therefore, green, right, has to be greater than number of red. So that's another possible inequality here. And also, they said that customer must buy at least 15 red balloons. So if you have to buy at least 15 red balloons, it means that X has to be greater than or equal to 15, right? Yeah, X is right. All right. 1 second, I just want to change something here. This here, right? They said greater than, right? You must buy more, right? You must buy more. So I'm going to change that inequality to Y is greater than X, right? So there are actually 4 different inequalities that we could use for this particular question, right? So that takes, oh, we still have one more piece, right? Y varies. So this is a proportionality question. So Y is inversely proportional. So you're going to take the words. This here, inverse, means 1 over. So if we write that into a proportional statement, it's going to be 1 over. So it's proportional to, inversely proportional to X minus 2. So this is what it's going to look like, right? To put this in brackets if you need to. So what you need to do, you need to replace the proportional sign with an equal sign. But the thing is, when you do that, you're going to put a constant in this here. So it's going to be K all over X minus 2, right? So this is my equation here. Now, normally when we are given a question on proportionality, we need to figure out what that K is. So they have given us information to figure out what K is, right? So the next step, we're going to say when X is equal to 11, right? Y is equal to 9, right? So what we're going to do, we're going to plug that into our equation here. So we're going to say 9 is equal to K all over X minus 2. In this case, we have 11 minus 2, right? So you're going to get 9 is equal to K, right? All over 9, right? So if you want to solve this, I know some students have trouble solving something like this. Just put the 9 as 9 over 1, right? And that will allow me to cross multiply. So if I cross multiply, I'm going to say that K is equal to 9 by 9. So therefore, K is equal to 81, right? So we worked out what K is, right? In this case here, my equation is now Y is equal to 81 all over X minus 2, right? So you have your equation now. And the question wants us to work out what is the value of Y when X is 29, right? So we're going to say when X is 29, right? Y is going to be equal to 81 all over 29 minus 2. So therefore, this is going to be 81 all over 27. So you're going to get 3 as your answer, right? So that takes care of number 2. Right? This next part here, we have a regular hexagon, right? So they have the word regular in bold. And that simply means that all these lengths here, they are all equal, right? So this is a hexagon. Show that the value of angle PQL. So PQL is this angle here, right? Now, we're looking at a regular polygon here, right? Now, there's a formula that we could use to work out what is the sum of the interior angles, meaning that when I add up this angle plus this, plus this, plus this, plus this, plus this, right? There's a formula to work that out. So that formula is given by n minus 2, right? Multiplied by 180. So n in this case, it's a hexagon, so it's a six-sided figure. So that's 6 minus 2 multiplied by 180, right? And when I work this out here, I'm going to get 4 by 180, and you're going to get 720. Now, what is that 720? That is some of the interior angles, right? So if I want to work out PQL, right, all I need to do is to take 720, and I need to divide that by 6, because you have 6 angles, and therefore you're going to get 120, right? So you're going to get 120 degrees. So that's your proof here, right? Part 2, we want to calculate angle LWX, right? That's this angle here, right? Now they told us that we have this rectangle that is touching the insides of the hexagon. So if we want to work out that angle there, now this angle here, because it's a rectangle, this is 90 degrees, right? Now you already know that this angle here, we just worked this out, we got 120, right? And the thing is, based on how this thing is drawn, this length and this length here, they're going to be the same. So therefore, that triangle WQZ is an isosceles triangle. So what we could do, we can work out this small angle here. See this angle here? You can work that angle out. All we need to do, we need to say 180, right, minus 120, and you're going to divide that by 2, right? So when you work that out there, you're going to get, that is 180 minus 120, 60. 60 divided by 2. Right? You're going to get 30 degrees here, right? So that angle is 30 degrees. So therefore, if I want to work out this unknown angle here, this one, right? To work this out here, all we're going to do, we're going to say 180, right? Minus about 90. And we have a 30, right? So in this case here, it is going to be 180, right? Minus 90 plus 30, 9 and 3 is 12. So this is 120. So therefore, that angle that we want to calculate here is going to be 60 degrees, right? Right? It's very surprising that it didn't bring a transformation question, right? So that's part 2. This next part here is with 5 marks. It's a construction question. So we have the field of a sports club is in this shape here, right? This shape here. And what we want to do, it's a scale diagram of a field, and they give us some information here, right? Now, in terms of the information given, they said a lamppost is to be erected on the field at a point L so that the floodlights can be installed. The point L is located in such a way that L lies on the perpendicular bisector of UR. So this is U, this is R, right? So if it's a perpendicular bisector, it has to pass through the center of that there. And what needs to happen as well is that it is going to be at right angles to UR. So this dashed line that I'm drawing here is the perpendicular bisector, right? That's 90 degrees here, right? That's a perpendicular bisector, right? The next thing they said now, they said lies on the perpendicular bisector of UR an angle LST, right? Now this is where T is, this is where S is. So somehow L is on this line here, right? So L is somewhere here, right? And what has to happen is that this angle here, because this LST has to be equal to 30 degrees, right? This angle here has to be 30 degrees. Now they said using a ruler and compasses only, locate the point L on the field, right? So visually, this is what's happening here. But what we need to do, we need to actually do some constructions and figure out exactly where the point L is, right? So I'm just gonna show you this here, all right? So the first thing I'm gonna do, I'm gonna use a compass, right? And I'm gonna find the perpendicular bisector of this UR here, right? So step one, you're gonna open your compass so that it is more than half the length of the line. That's step one, right? And we're gonna draw a large arc here. All right, that's step one. We're gonna draw a large arc here. Next thing we're gonna do here, we're gonna put your pointy part at R. We're gonna draw a second arc, right? And then what I'm gonna do, I'm gonna use a ruler, right? And in the ruler here, we're gonna draw right? So this line that I'm drawing here, this red straight line that I'm drawing here, that is a perpendicular bisector of the line UR, right? That's a perpendicular bisector of UR, right? Now, the next thing we're going to do now, we need to construct a 30-degree angle, right? A 30-degree angle at this point here, right? At the point S. So here's what you're going to do. Let me use a different color. All right, so step one, what I'm going to do, I'm going to take my pointy part here, right? Which is not this piece. Hold on. Yeah, let's put the pointy part by S. And what we're going to do, we're going to construct, right? We're going to construct a 30-degree angle at that point, right? How do you do that? First thing you're going to do, right? You're going to draw an arc here. That's step one, right? And the next thing we're going to do, if we put an arc here, right? What we've created there is a 60-degree angle. Now, just for illustration purposes, right? What I'm going to do here, I'm going to draw a line, right? I'm just going to use this for now, right? But I'm just going to draw a line here, right? So this green line here, right, will give me this angle that I have here. This angle here currently is 60 degrees, right? But I don't want 60 degrees. I want 30 degrees. So all I need to do is to bisect that angle. So that's what they expect us to do here. We're going to bisect that angle here. So to do that, right, all I need to do, because I have that same arc available to me here, I could just come here. Right, that's I'm trying to get approximately the same spot, right? Yeah, so what you're going to do, if you want to bisect this angle, you can draw an arc up here, right? Then come to this point here, right? And draw another arc here, right? If I were to draw a line, and maybe I should use a different color here, maybe blue, right? Let's go with this. Yeah, so from the point S here, right? See this line here that I'm drawing? That line here will represent my 30-degree angle, right? So this angle here this here is 30 degrees. This angle here is 30 degrees. So therefore, the point L that we're talking about, where we're going to put the lamp pole, right, is going to be here, right? This here is the point L. It's the point of intersection of the blue line and the red line, right? So I hope that makes some sense, but that's where that line is going to be. Right, so 5 marks for that construction there, right? Next part now, this question 4, right? So if you all were following my free crash course, you would realize that similar questions, I would have done similar questions within those classes. right? So we have points C, which is negative 5, 6. Right? We have D, which is 7, 2. Right? And we want to calculate the midpoint of CD. So there's a formula for midpoint, not given to you in the exam, but you need to know it. That's x1 plus x2 all over 2. And we have y1 plus y2 all over 2. Right? So basically, what I would normally tell students to do is to label your points. So let's label this x1. Let's label this y1. Let's label this x2. And let's label this y2. Right? Once you label it, then there's no reason why you shouldn't get this correct. So we're going to add the two x values. So it's going to be minus 5 plus 7 all over 2. All right. And then we have 6 plus 2 all over 2. Right? So minus 7 plus 5, you're going to get 2. So that's 2 over 2. 6 and 2 is 8. That's 8 over 2. Right? And then when you work this out here, you're going to get 1, 4. Right? So that's our midpoint is going to be 1, 4. Next part, we want to find the gradient of CD. Right? So let me just copy back this information here. So there is a formula to find gradient, right? There's a formula to find gradient, and that gradient is, so let's call it gradient, or you can call it M. We call it M, small m. So the formula for gradient of any line segment is y2 minus y1 all over x2 minus x1, right? In this case here, all y2 is 6. So it's going to be 6 minus 2. Oh, sorry. Hold on. My y2 is 2. Right? So it's 2 minus y1. So that's 2 minus 6. Right? And this is going to be 7 minus 5. So when you work this out, 2 minus 6 is going to give you minus 4 all over 7 minus 5 is going to be 7 plus 5. That's 12. You can reduce this, and this is going to be minus 1 over 3. So that's our gradient of our line segment C. Part C, you want the equation of the perpendicular bisector of CD. So it's a negative gradient, right? So this is C, and this is D, right? Now the perpendicular bisector is simply a line that must pass through the center or the midpoint, right? And it's also going to cut at 90 degrees here, right? So that green line there is what we're trying to work out. So the thing is, we know the gradient of CD. So M for CD is minus 1/3, right? So therefore, M for the perpendicular line has to be equal to 3, right? Because they are perpendicular lines. When you multiply the gradients of perpendicular lines, you get negative 1. So you're going to say that. So you're going to say the gradient of CD is minus 1/3, right? So therefore, the gradient, right, of perpendicular, right, I'm just going to put a little symbol here, has to be equal to positive 3, right? Because 3 multiplied by negative 1/3 will give me negative 1. So now the thing is the midpoint, we work the midpoint out and we got 1, 4. So this point here, we actually know this coordinate, that's 1, 4, right? So if I want to work out the equation, so all equations of straight lines follow this format, y equal mx plus c, right? But you know the gradient already, y is equal to 3x plus c. So all we need to do is to figure out c. Now the problem here is that you need to make sure you're using the midpoint to work this out, right? So with the midpoint, when x is 1, y is 4, right? That's what the midpoint is telling me. So all I'm going to do, I'm going to substitute those numbers into my formula. So you're going to say 4 is equal to 3 by 1 plus c, right? So 4 is equal to 3 plus c. So therefore, c is equal to 4 minus 3, which is 1. Right? So the equation of the perpendicular bisector is simply going to be y is equal to 3x plus 1. Right? So that's your answer for that part. Next part here. Another line AB is parallel. So we have CD again. Right? We have CD. And what they're talking about now, they're talking about a parallel line. So we have some line that is parallel to CD. Right? Now the thing about parallel lines is that they have the same gradient. So if the gradient of CD was minus 1/3, right? What that tells us is that the gradient of this green line here should also be minus 1/3, right? But they also told you that the line passes through the point 0, 1, right? Now, if you notice in the question, they said write down the equation of the line AB. So there's no calculation involved here. So this is going to be y is equal to, we know what the gradient is, it's negative 1/3. So it's negative 1/3 x. Now the thing is, they gave us this point here, 0, 1. Anytime you see a coordinate starting with 0, that's your y-intercept. So this is simply going to be plus 1. That's it, right? So that takes care of part D. This next one here is question 5, I believe. Yeah, question 5. Right? So the table shows the marks out of 10 that 40 students in a class gained in an essay writing test. Calculate the students' mean score. So we have data in a table here. We have marks, we have students. What we need to do, we need to create a new column here called XF, right? So we need to take each mark and multiply by the number of students. So 4 by 3 is 12. 9 by 6 is 54. 7 8s are 56. 7 8s are 56 again. 9 8s are 72, right? And 10 5s are 50. Right? Now, if you want to calculate the mean using a table, right? So mean is given by x bar, and this is going to be sigma xf all over sigma f, right? That's our formula to find mean from a table. Don't get confused by the word sigma, right? Sigma is just the sum. So in this case here, we need to add up everything in this column here, right? When you add that up here, that will be called sigma xf. And when I add this up here, I'm going to get 300, right? So your sigma xf is 300. Divide that by sigma f. So sigma f is simply the total number of students, which is 40, right? And when you work this out here, you're going to get 7.5, right? So that's our mean for part 1. Part 2, we want to determine the modal mark. So mode is the one that has the highest frequency. Your highest frequency here, or highest number of students, is 9. So therefore, the modal mark is going to be 6, right? So the modal mark here is going to be 6. Now, the median. Now, sometimes students have trouble working out the median from a table like this, right? And what I normally teach my class to do is this. You have a total of 40 students, right? The first thing you're going to ask yourself, is that number an odd number or an even number? If it's an odd number, we're going to get an exact middle. If it's an even number, we don't get an exact middle. So here's what you're going to do. So what I normally do, I'll draw a line like this, right? So you have 40 students. So 40 divided by 2, because remember median is middle when I've arranged my data in ascending order. When you have data in a table, more than likely it's already in ascending order. So in this case here, it'll be 40 over 2, which is 20. Now, there's no exact middle, right? So this here is your first student, and this here is my 40th student, right? Now, like I said, there's not going to be an exact middle, right? So this is where my median is. So this is where my Q2, right? That's normally the symbol we use for median, Q2. So if we divide our data into 2 equal parts, it means that on the left side here, I have 1 to 20. So this here represents my 20th student. And then from the 21st to the 40th, right? That's the other half of the data, right? So this is my 21st student. So if I want to work out the median, I need to figure out what is the score of the 20th child and what's the score of the 21st child. If you go to the table, sorry, if you go to the table, right, and we start checking, you have 3 students here, you have 9 students here, that's 12. 12 plus 8, that's 20, which means that the 20th child had a score of 7, right? So the 20th child had a score of 7. And if that is the 20th child, right, it means that the 21st child falls in this group in here, right? So that child would have scored 8 as their mark. So therefore, the 21st child scored 8. So I'm going to use these two numbers here, this and this, in order to work out your median, right? So the median in this case here, right? What we need to do, we're going to take 7 plus 8, and we're going to divide that by 2, right? And you're going to get 7.5, right? So you have to be careful with this particular question. Next part, we have a table again here, right? With some marks again, but we have them in groupings, right? And we want to represent this on a pie chart. And I want to know what is the angle that will represent this interval here, 5 to 6. So 5 to 6 is 9, right? They didn't say if the table is from the data above, but 9 and 3 is 12, right? Plus 15 plus 13. So this is 40, right? There's 40 students here. So if you want to work out the angle, it's going to be 9 all over 40. And you're going to multiply that by 360 degrees, right? Right? And in this case here, when I work this out, I'm going to get 81 degrees, right? So that's my angle there. Now, this is the first time I've seen a question where they asked so much about probability, right? I know one or two students had trouble with this question. So you have 2 fair-sided dice, right? Now, the word fair is being used here. And what that tells me is that the probability of getting any face is 1/6, right? A die has 6 faces, so the probability of falling on any one of them is going to be 1/6. That's what the fair is telling us here, right? A die could be biased, right? You can throw a die 100 times and it could keep getting, let's say, a 2 or something. That's a biased die, right? So the thing is, what they did here, they kind of gave us some die, but it's not numbered 1 to 6. Like it's numbered 0, 0, 1, 1, 2, 3. That's die P. And die Q is numbered 1, 1, 1, 2, 2, 3, right? So when the die is rolled, the score is the number on the top face. Now, we're going to take die P and you're going to roll it once. What's the probability of not getting a 2? So in the case of die P, our options are 0, 0, 1, 1, 2, and 3. Now, you don't want to get a 2, right? So you don't want to get this, which means that I could get a 0, a 0, a 1, or a 3. Those are the possibilities here. So therefore, that is 5 different ways, or 5 ways I cannot get a 2 out of a total of 6 possibilities, right? So for this one here, the probability of not a 2, right, is going to be equal to 5 over 6. So this one is not too bad. The second one, die Q is rolled twice. What's the probability that you get a 1 both times, right? So the numbers on Q, so this is second die we're talking about here. So we have 1, 1, 1, 2, 2, 3, right? So this is die Q, and the options are 1, 1, 1, 2, 2, 3. Right? Now, they said you want to get a 1 both times. So the probability of getting a 1, right, is, if in terms of number of ones here, we have 1, 2, 3 ones. So the probability of getting a 1 is 3 over 6, or a half, right? So that's the probability of getting a 1, right? Now, the thing is, we want to get, so the probability of getting a 1 and a 1, right? So the probability of getting a 1 the first time is going to be a half, right? Now, the fact that you're doing this twice, right, and the probability of getting a 1, these are independent events. You're going to multiply your probabilities. So it's going to be a half multiplied by a half, and you're going to get a quarter, right? So the first rule, you're going to get the probability of getting a 1 on the first rule is a half. And then when we roll the die again, right, the probability is also a half. So you have to multiply the probabilities here. Next one here. Die Q is rolled 72 times. Calculate an estimate for the number of times you would score 3. So this is die Q. So that's 1, 1, 1, 2, 2, 3. Right? So that's 1, 1, 1, 2, 2, 3. Right? Now the probability of getting a 3, right? So in this scenario here, you only have 1 3. So this is 1 over 6, right? Now you're rolling this thing 72 times, right? Estimate the number of times you get a 3, right? So in this case, all we need to do is to take 1/6, and you're multiplying that by 72, right? And you're going to get 12, right? So an estimate for the number of times you can get a 3 would be 12, right? Now, each die is rolled once, and the product of the scores is recorded. The sample space diagram is shown below. Now, this is I've never seen them bring an exam question with sample space, right, in the CSEC maths exam, right? Typically, we'll see this in the AdMaths exam, right? So this question here, some students may have had some trouble with this. But what we're doing here, this is called a sample space diagram. This is the outcomes for die Q, and this is the outcomes for die P, right? Now, these numbers here represents the numbers that we see on the die, right? That's what that is. And this here represents the other set of numbers for die P. Now, they said that when you roll each of these die, right, you are multiplying the number that you see. So, for example, if you got a 3 on die P, and let's say you got a 2 on die Q, when I multiply the two numbers, I'm going to get 6, right? So that's what the diagram is showing us. So the question says, what's the probability of getting a 2 or a 3? So what you do, you go to the diagram and you're looking to see where we have a 2. So all of these are 2s here, right? And let's circle the 3s as well. 1, 2, right. So therefore, that probability that we're looking for here, right? So that's 2, 4, 6, 8, 10, 12. So that's 12 all over the total number of possibilities. Based on the sample space diagram, you actually have 1, 2, 3, 4, 5, 6, right? 7, 8. And if you count, you're going to get 36, right? So there are 36 possibilities here, right? So this is going to be 1/3. Right? So this may have been a strange question for a lot of students, right? Next question here, right? We're taking pi as 22/7. So you have a piece of wire. It's bent 61 centimeters long, and it's bent in the form of a sector, right? And what we want to do, the radius of the sector is 18, and I want to show that angle X is approximately 80 degrees. So here's what's happening here. If this is 18, right, it also means that this length here has to be 18, right? That length is 18. And this here is what you call your arc. So the arc PQ is simply going to be 61, that's the full length of the wire, minus, right, 18 plus 18. So what I'm doing here, first of all, I'm trying to work out what is the length of the arc, and you're going to get 25 here, right? Now, I'm going to use that information in order to work out the angle X, right? Now, you may not know this, but this formula is actually given to you in the exam. So if I want to find the length of an arc, it is theta over 360 multiplied by 2 pi r. That's how we work out the length of an arc, right? Now, in this case here, that length of arc is actually equal to 25, right? So what we have here is theta over 360 multiplied by 2 multiply by 22 over 7, right? Multiply by r, which is 18, and that is equal to 25, right? So to work this out here, right? All we need to do, we can see. So what I'll do, put theta over 360 here, right? And I'm working out 2 by 22 over 7 by 18, and you're gonna get 792 over 7, and that's equal to 25. So therefore, theta over 360 is equal to 25, right? Divided by 792 over 7, right? So this will be, I'm going to work in decimals now. So this is, right? And this is 0.221, right? So therefore, theta, if I want to work out the theta is simply going to be 0.221 multiplied by 360, right? And I'm going to get 79.5. Right? So that's the angle that I'm getting here, right? And if I round this off, I'm going to get 80 degrees, right? So that's my angle, right? So this angle here, they tell us to show that it's approximately 80. That's what we just did, right? Next part, we want to find the area enclosed, right? So that's the area of a sector that you're working out. So you're working out this whole area here. That's what you do, right? Again, there's a formula for that on the formula sheet. So that's theta over 360, right? Multiply by pi r squared. Now, the thing is, they wanted us to show that this thing is approximately 80, but in our calculation, I'm getting 79.5. So I'm just going to use the 80 over 360 by pi. We said pi is 22 over 7. Multiplied by the radius squared, which is 18. Right? So in this case here, when I work this out, I'm going to get 226 cm squared. Right? So that's the area enclosed by the wire. Right? Now, this question is very interesting because I gave you all a sample, one of my sample questions, and I give a slice of cake. This one here, they have a slice of cheese, right? So a cylindrical block of cheese has a radius of 12 cm and height 8 cm, right? The cheese is divided into equal slices. Now, what they've shown us here is one slice. The uniform cross-section of the slice is a sector whose angle is 18. So we have one slice of cheese. And you want to work out what's the length of the arc AB, right? Now, if you didn't know the formula to work it out in the first part, then this is going to be problematic. So the length of the arc AB, so that's this curved piece here. This curved piece here. So that length of arc is given by theta over 360 multiplied by 2 pi r. Right? In this case here, our angle is 18 over 360 multiplied by 2 pi r. So we're going to take the pi as the same 22 over 7. Multiplied by the radius, which is 12. And you're going to get 3.77. Right? So that's the length of the arc AB. Next thing we want, they said determine the area of the curved face ABCD. So they're talking about this curved face here, right? Now, even though it's curved and you want to work out the area, that's technically a rectangle, right? And the top part of the rectangle is 3.77, and this piece here is 8 cm, right? So it's a rectangle, so that's going to be 3.77 multiplied by the height, which is 8. Right? And you're going to get this area as being 30.16. right? It's area, so it's cm squared. Now the next part, given that the area OAB is 22.6, right? So this area here is 22.6, right? They want us to work out the volume of the entire. Now notice they put this in block here, right? So what I would do, I'll work out the volume of that one slice. Right? Volume of that one slice here is simply going to be the area, which is 22.6, multiplied by the thickness, which is 8, right? And you're going to get 180.8 cm cube. It's volume, so it's cm cube. Now, the thing is, that's just the volume of the slice that they gave us here, right? But the question says they want the volume of the entire block. So what I'll do, I'll work out how many slices we have by taking 360 and divide that now by the angle here is 18. So 360 over 18, right? And you're going to get 20 slices, right? So you have 20 slices of cheese. So the total volume is simply going to be 20 slices multiplied by that 180.8, right? And you're going to get 3616 cm cube, right? So that's the volume here. Next one, question 7, right? So we have a sequence of patterns made by dots and lines of unit length. We have some squares and we have, okay, so there's a pattern, right? And we want to complete the fourth diagram. Now, what you normally need to do is when you jump from one diagram to the next, we need to figure out what is actually changing, right? Now, if you watch what's happening here, all you've done is added this piece here, right? When you jump from diagram 2 to 3, right? Again, all you've done is added this piece here, right? So if you want to complete this diagram here, we're going to add that piece. So we're going to put a square here, put our dot in the middle, right? Then we have to put this here, this line here, this line here. We need to put this line here, and we need to put a dot here and a dot here, right? So that's an easy to mark, right? Just to complete the diagram. Now, they want us to complete this table here. So we have diagram number, we have dots, and we have lines. So we want to complete this, right? Now, we just drew figure 4, right? We just drew figure 4. And what we need to do, we need to complete how many dots do we have in figure 4. So if we count the number of dots here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 14 dots, right? So that's the number of dots here is 14. If we were to check the number of lines, right? We check here, each line here, we'll end up with 29, right? So there are 29 lines when we count it in figure 4. Now, what I normally tell my students to do, always work out what is the pattern rule first before doing anything else in the table. So let's work out for the nth diagram. So to do that, all you need to do, you need to see what's happening in terms of your numbers. When I jump from here to here, I'm adding 3. When I jump from here to here, you're also adding 3. And when you jump from here to here, you're adding 3. Now, these patterns are easy to figure out if there's a constant increase, right? So since you're increasing by 3 all the time, it means that our formula should have 3 in it. So it will be 3n. What I will do, I'll plug in diagram 1 into my formula. So that's 3 by 1. But the thing is, I want to get 5 as my answer. So therefore, I still need to add 2. Right? So that's your formula for finding the number of dots. If we were to go to the number of lines now, right? When you jump from here to here, from 8 to 15, you've added 7. When you jump from here to here, you've added another 7. And when you jump from here to here, you added 7 again. So as I said, these patterns are easy to figure out if there's a constant increase. So therefore, 7 needs to appear somewhere in the formula. So therefore, it's going to be 7n. So let's plug 1 into that formula. 7 by 1 is 7, but the thing is you want to get 8. So therefore, you're missing 1. You have to add 1 in order to finish this, right? So I've worked out the general pattern for the number of dots and the number of lines. Next thing now, we want to complete this row here. So we have 59, right? So what I could do is figure out what figure number is that by plugging 59 into this formula here. So we could say that 3n plus 2 is 59. All right. 3n is equal to 59 minus 2. All right, is 57. N is 57 over 3. So n is equal to 1, 9. Right, so n is 19. That's figure 19. So this is going to be 19 here. And to work out the number of lines, we just take that 19 and you plug it into the other formula. So this is 7 by 19 plus 1, right? And you're going to get 134. Right? So that's the number of lines that we have in figure 90. Next thing here now. One of the diagram in the sequence has 48 lines, and we want to calculate how many dots it is. Right? Now, I don't know why they put it separate. They could have just put this in a table. That wouldn't be a problem. So L, number of lines, is 148. Right? So the number of lines is given by the formula 7n plus 1. So you're going to put 7n plus 1 is equal to 148. All right. So 7n is equal to 148 minus 1. 7n is 147. And n is equal to 147 over 7. So therefore, n is 21. So that's the figure number. Figure number is 21. And we want to work out the number of dots. So the number of dots is given by the formula 3n plus 2. All right, so this is going to be 3 by 21 plus 2. All right, and that's going to give us 65. All right, so this question was reasonably enough, right? Reasonably enough. So that takes care of question 7, right? Question 8 is based on functions. So they give us two functions, f and g, and they want to work out f of minus 2. So f of x is equal to 1 plus 3x all over x minus 1. And you want to work out f of minus 2. So you're going to plug minus 2 into this formula. So this is 1 plus 3 by minus 2 all over minus 2 minus 1. So this is going to be on top here. That's 3 by minus 2 is minus 6. 1 minus 6 is minus 5. And then minus 2 minus 1 is going to give you minus 3. So this could be written as 5 over 3. Right? So that is f of minus 2. It is 5 over 3. Next part, we want a simplified expression for fg of x, right? Let me just... All right, so these are two functions here, and we want to work out a composite function, and that composite function is fg of x, right? Now, if it's a composite function, what you're going to do, you're taking this here, g of x, and you're going to plug that into f, right? That's what you do. You're taking g of x and you're plugging that into function f, right? So what we're doing, we're taking this, and anywhere we see x in the function, you're going to put 5 minus x. So this is going to be 1 plus 3 by 5 minus x all over x minus 1, which in this case is going to be 5 minus x minus 1. So we need to simplify this. On top here, when I simplify, I'm going to get 1 plus 3 by 5 is 15 minus 3x all over, right? I could simplify the bottom one time. 5 minus 1 is 4. So this is going to be 4 minus x. So therefore on top, it's going to be 16 minus 3x all over 4 minus x, right? So that's my composite function here. We want to derive an expression for the inverse. So this is one of those hard ones that it could give us, right? So there are several steps that we follow. So step one, we're going to let y equal to 1 plus 3x all over x minus 1. Next thing we're going to do, you're going to interchange x and y. So we're going to put x is equal to 1 plus 3x, 1 plus 3y all over y minus 1, right? And the final step now is to make y the subject of the formula. So I'm going to put this over 1. And then what I'm going to do, I'm going to cross multiply. So this is going to be x by y minus 1 is equal to 1 plus 3y, right? If I simplify the left side, I'm going to get xy minus x is equal to 1 plus 3y, right? Now carry all the y's on one side. So you will end up with xy minus 3y is equal to 1 plus x. On the left side here, we need to factorize. So this is going to be x minus 3, right? So this is going to be y is equal to 1 plus x all over x minus 3, right? And we're going to just write the inverse is 1 plus x all over x minus 3, right? Let's double check, make sure we're okay. Right? I think we're okay there. All right, so that takes care of that part here. Now, this part here now, the velocity time graph describes the journey for a car over 70 seconds, right? The journey is represented in 5 stages. So we have 5 stages here, all of them labeled. Complete the following statement. During stage 4, right, that's what this is, stage 4, the car is traveling at what? Where is stage 4? So this here is stage 4. Now, in terms of velocity, the car is traveling at 45. So this here is going to be 45, right? With an acceleration. Now, anytime you have a constant velocity, right, the acceleration is going to be 0. Or remember, when you're working out acceleration from a velocity time graph, you have to find slope. This horizontal line here has a gradient equal to 0. So this is going to be 0. That's what I want here, right? And part 2, they want the maximum acceleration of the car during the 70 seconds. Now, acceleration is given by the slope of a line, right? Acceleration is given by the slope of a line in the case of a velocity time graph. So what you can do, right? You can work out the velocity in this stage, that's stage 1, stage 3. Now, stage 4 is an acceleration, but it's a negative acceleration, right? So let's see. In stage 1, right? Let's work out the acceleration. So all I need to do is to complete a right angle triangle. That's the easiest way to do this, right? In which case, we'll take the vertical height, which is 20, right? So you're going to take 20 and you're going to divide by 15, right? That's the horizontal length. So that's 20 over 15, right? So that's 1.33. So this here is 1.33 meters per second squared. That's acceleration in stage 1. In stage 3, right, we do the same thing. So we draw a triangle here, right? And you're looking at the height of the triangle, in which case you have to take 45 and minus 20. So that's 25. So in stage 2, the acceleration is going to be 25. Yeah, 25. That's the height of the triangle, divided by the base of the triangle, which is going to be, that's going to be what, 10? So therefore, this here is 2.5 meters per second squared, right? So that's the acceleration in stage 3 and the acceleration in stage 5. Now, because of how that line is sloping there, it's going to have a negative slope, right? So this, the gradient of this line here is going to be negative. That's this stage 5. So the acceleration is going to be negative. So the vertical height of that triangle is 45, right? And you're going to divide that by this here, which is 20, right? But because it's a negative acceleration, you need to put a negative sign here. So that's 45 divided by 20, and you're going to get negative 2.25, right? Now the question says, determine the maximum acceleration. If you look at the numbers here, the maximum acceleration occurs in stage 2, right? This is 2.5, right? So this here represents my maximum acceleration, right? This one here, right? So in terms of the graph, this is the steepest part in the whole graph, right? So that's, so your maximum acceleration is going to be 2.5 meters per second squared. And the next part, calculate the distance traveled during the first 25 seconds. So if you want to work out distance traveled, right, all we need to do is to find the area under the graph. And we're going up to 25 seconds. So you have to work out this area here. So you can break it up into that triangle and this rectangle if you want, right? So the triangle will be, so this here, the triangle part is a half by the base of the triangle, which is 15 and the height is 20. So this is 15 by 20, right? Plus, we have to add the rectangle piece now. So the rectangular piece here, this is 15. This is 25. So that's 10, right? So this length here is going to be 10 and the height is 20. So it's 10 by 20. Right? So a half of 20 is 10, 10 by 15 is 150 plus 20 by 10 is 200. So this is 350 meters, right? That's the distance traveled in the first 25 seconds, right? Moving on to question 9 now. The diagram shows a circle with center O and the points P, Q, L, and N lying on the circumference, right? And we have two lengths that are equal, right? RM is a tangent, right? To the circle at L, and they give us an angle of 63. Explain why angle X, right? So they're talking about angle X, that's this angle here, right? And NQL, NQL, right? So angle X and this angle here, they're the same, explain why, right? So what we're looking at here, you will notice that both those angles are made using this chord here, right? So here's what you're going to tell them. You're going to say NL is a chord right? NL is a chord, and you can see that angles in the same segment are equal, right? Because that chord is dividing the circle into two segments. So the angles that you make on the circumference, they are going to be equal, right? So angle X and NQL, they have to be equal. Now, we want to determine each of the angles showing detail working where possible. So we want to get angle X, right? Now, the thing is, angle X here, right? Now, this is a tangent. All right, this here is a chord, right? Now, one of the rules for circle geometry is that the angle made between a tangent and a chord, right, is equal to the angle in the alternate segments. So this here, right? Even though we have to calculate, this angle here is going to be 63 degrees, right? So the angle is 63 degrees. Now, the reason for this is that the angle, right, between a tangent and a chord, right, is equal to the angle in the alternate segment. Right, so this is one of those rules here that we applying, right? Right, so 2 marks for, well, 1 mark for saying 63 degrees and 1 mark for the reason, right? Next angle we want to calculate is angle Y. How we calculate an angle Y, right? Okay, so here's how we calculate an angle Y, right? Now, if angle X is 63, it means that this angle here is also 63 degrees, right? That angle is 63 degrees here. Now, the thing is, if we look at the diagram, we have an isosceles triangle. So if that is 63 degrees, it means that this angle here is also 63 degrees, this angle here, right? So therefore, if you want to calculate angle Y, so what we need to say is that LNQ is isosceles. Right? And LNQ is isosceles. So if you want to work out angle Y, it's going to be 180 minus 63 plus 63. Right? I'm not sure why they're asking for detailed working here, because these are rather simple. Right? So this angle here is actually going to be 54 degrees. Let me look at that again. Yeah, that's what it'll be, right? Part B now. So we have a bearings question here. We have two ports E and G on level ground, right? 245 kilometers apart. The bearing of E from G, right? The bearing of E from G is 302 degrees. A ship is anchored at F, some distance away from G, on a bearing of 228. All right. Angle EFG is 52. So on the diagram, insert the 228, right? Insert the 228. Now, first things first, I want to insert more than that, right? Because it said the bearing of E from G is 302. So if I draw a north line, so if I come here, right, this here is 302 degrees, right? I'm just putting this here. They didn't ask me for it, but I know I'll need it in a sec. Okay, so the bearing of F is some distance from G on a bearing of 228, right? So the bearing of 228 there, they're talking about, you know what? I'm going to remove this here. I'm going to just put the 228 first and work from there. All right, this here, up to this point, is 228. Right? That's what I wanted on the diagram. So that's your 228 there. They want you to determine angle FEG. FEG, that is this angle here they want, right? Now I'm going to use, let me use that bearing that they gave me up here. So they gave me a bearing of 302. That's the bearing of E from G, right? So let me show you what we're doing here, right? So you're taking, if I do this 4. Right? This green angle here, right? That green angle there is 302 degrees, right? So what I could do, right? Let me use some more colors here. I can actually work out this angle, right? That blue angle there is simply going to be 302. right, minus 228. You're going to get 74. All right, so this angle here, this blue angle here is 74 degrees, right? So if you want to work out this, right, this is what it's asking us to work out. It'll be 180 minus 74 plus 52. And you're going to get 54 degrees. Right? So that's my angle there. So this one here is 54 degrees. Right? Now part 2, they said calculate GF, the distance, calculate GF, the distance the ship is from the port G. So GF, let's look at the diagram. So you want to calculate GF, right? So for this one here, we could use the sine rule, right? We could use the sine rule, yeah. Right? So let's see how we're going to use the sine rule. So we can say you want to calculate GF. So let's take GF over sine 54. Right? GF over sine 54, sorry, right, is 245 over sine 52. Right? And because we're using sine rule here and you want to solve for GF, we can just cross multiply. So GF by sine 52 is equal to 245 multiplied by sine 54. So therefore GF is equal to 245 multiplied by sine 54 all over sine 52. So that's 245 by sine 54 divided by sine 52. And you're going to get 251.5. Right? And that is meters. Right? So that's part 2. Now they said indicate the point H on the line EF such that GH is the shortest distance from G. All right, hold on now. I need to I just want to bring that diagram closer while I'm reading the question, right? Make sure we interpreting what is being asked. Right, so I need the diagram. Right, so this is the diagram here. Let's see what they're really telling us here. So indicate the point H on EF, right? So H is somewhere in EF such that GH is the shortest distance, right, from G. All right, so basically what they want us to locate a point here, right? And this point here is H, right? But you want H to be the shortest distance, right, from G to the line EF, right? Now the shortest distance between G and that line EF here is going to be a straight line, right? And the shortest distance here, that means that this angle here is going to be 90 degrees, right? So that's the point H here. And then they want us to calculate GH. So hold on, let me just put in my angles again. I need some of the angles here. That was 54 and 74. So this is 54. And this here is, well, we don't need that, right? We already don't need that. So you want to calculate the distance GH. So now we're using a right angle triangle, right? Where this here is your hypotenuse, right? The side opposite the angle is your opposite. So this is opposite, right? And therefore this is adjacent, right? So it's a right angle triangle we're playing around with now. So if we use, so car tour. Based on what we have here, we have the hypotenuse and we want to calculate opposite. So therefore, we're going to use sine, right? So we could say that sine theta is opposite over hypotenuse. So sine 54, right? Your opposite there is GH. That's what we're trying to work out. All over your hypotenuse, which is 245. To put this over 1 and cross multiply. So GH is equal to 245 multiplied by sine 54. And you're going to get about 198.2. Right? And this is kilometers. Right? Let me back up a second. I think about meters for this one here. This should have been kilometers up here as well. Right? I thought the diagram was in meters, but it's kilometers. Right? So that takes care of question 9. And this now is question 10. Right? The diagram below shows a quadrilateral OLMN. O is the origin, OL is 4y, OM is 6z, ON is 2x. All right. The point E lies on M such that LE to MN is 1 to 2, and the point B, okay. So they give us some info here. And the first thing they want you to work out MN. All right. So go to the diagram and you want to work out MN. So that's this vector here, right? And you want the answer in terms of x and z. So if you want to go from M to N, we can go MO, right? So MN is equal to MO plus ON, right? Now in this case here, MO is the opposite direction, so it's minus 6z, right? Plus ON, which is 2x, right? So that's the vector MN here, right? Minus 6z plus 2x. Right? Now, in terms of x and y, find in terms of x and y the simplest expression for ln. Where's ln? All right, so we want, right? So there's a vector ln here that we want to work out, right? And what do we want that in terms of? Right, in terms of x and y. So this one is also easy. So ln, right? Based on the diagram, you can go from L to O, right? Plus O to N. Right? Which in this case here, LO is 4y. But because we're going in the opposite direction, it's going to be minus 4y. Right? Plus ON, which in this case is 2x. Yeah, right? So minus 4y plus 2x. Right? What else do you want me to do here now? Show that AB is that. So where is AB now? So we need to work out this vector AB here. Right? Now let's see how we're working out AB. Right? I'm just trying to find the easiest route I can use to figure out AB. Right? How many marks is this? Right? They're only giving you 2 marks. All right, so this is what I would do, right? I want to go from, I want to get AB, right? You want to get AB. That's the vector you want to get. Right? Go back to the diagram here. If I want to go from A to B, right, I can go from A to M and then M to B. That's a possibility. Yeah, we could go that route. A to M. Plus M to B, right? Now I'm trying to use what information I have. I have this so I can work out MB. That's not a problem, right? This here. All right, I have no choice. I had to work out LM, right? I was trying to find a much easier way to do this, but I still need to figure out, right? So here what? I need to figure out LM first, right? I thought there was an easier way, right? LM is actually, let me see something here. The answers in terms of X and Y, all right? I'm making it a little complicated for you guys, right? All right, let me work out LM. LM could be LO, ON, and NM. LO plus ON right, plus NM. Now, the only reason why I go in this route here is because the answer here is in terms of X and Y. So I don't want any Z inside it, right? Now, LO is minus 4Y, right? Plus ON, which is 2X, right? Plus NM. Now, NM is really the reverse of this. We just work this out here, but this has a Z in it too. All right, I have no choice. Let me just go work with this, right? So I was trying to find the easiest route to do this. All right. All right, anyways, I'll just go ahead with what I'm doing right now, right? If I want to go from N to M, that's going to be 6Z minus 2X, right? So this is 6Z minus 2X, right? So this is going to be minus 4Y plus 6Z, right? Right? Which is what we would have gotten the other route as well. So that's okay, right? So that's LM. Now let's go back to this AB thing here. So to get AB, right, we are going from A to M, right, and M to B. Now A to M, let's use the ratios that they gave us. So they said that LA to AM is 1 to 2. So therefore, if I divide this line, right, if the ratio is 1 to 2, you're dividing this line into 3 equal parts. So if you want to get AM, AM will be 2/3 of LM, right? 2/3 LM. So this is 2/3 LM, right? Plus MB, right? Let's go back to the diagram here. MB. Now, based on the ratio again, right? MB to BN is 2 to 1. So again, this is divided into 3 equal parts, right? So MB is 2/3 MN. Right? Now, what we could do here, you could pull out 2/3, right? And this is LM plus MN, right? Now, LM, you know actually what LM is, right? I just worked it out there. We have minus 4Y plus 6Z, right? Plus MN. We had MN from the beginning. MN was minus 6Z plus 2X. Right? I don't understand why this is only 2 marks, right? Because this is plenty working to show this, right? All right, let's see. So 2X, there's nothing to do with the 2X. This 6Z will cancel with this, and you'll have minus 4Y, right? Which is what they wanted us to prove, right? So I was trying to find an easier way to show it because I find it was plenty marks, all right? Now, what we want to do now, based on your results in part 2, state the geometric properties of LN and AB. So AB, the vector AB was 2/3 2x minus, right? And what's the other one? ln, right? We worked out ln before. Where is that? You can write that as 2x minus 4y if you want. Right? ln is 2x minus 4y, right? Now, they want two geometric properties, right? Two geometric properties, right? Now, the thing is, if you look at this here, you realize that one is a scalar multiple of the other, right? So since, right, AB is a scalar multiple of ln, right? What we can say is, so the geometric properties that they're talking about here, right? We can say that AB is parallel, right, to ln. So that's one geometric property. Since one is a scalar multiple of the other, one has to be parallel to the other, right? And the fact that we have this 2/3 here, right? What that is telling me, we can say that AB, right, is actually 2/3, right, of ln, right? So in terms of length, so this is one geometric property here, right? The second geometric property, just based on that fact there, is that the length AB is actually 2/3 ln, right? So that's what's happening here. So the length of AB, right? The length of AB is, so you can write it like this if you want. The length of AB is 2/3 the length of ln, right? So if you go back to the diagram, you can actually see that it looks like AB is parallel to ln, and we can say that the length of AB is 2/3 ln, right? So those are the geometric relationships we're talking about it. And part B now. So I did a question like this in the crash course, right? So you want to work out the unknowns. So in this question here, we have a x that is unknown and we have a y that is unknown. Now you're adding two matrices on the left side and you have an answer on the right side. So let's look at the corresponding positions, right? So I can say that 4 plus x is equal to -3, right? So therefore x is -3 minus 4, right? So therefore x is -7, right? Then also, if we look at the positions here, right, there's -2, there's 8. So -2 plus 8 is equal to y. So -2 plus 8 is going to give me 6. So therefore y is equal to 6, right? So you worked out the unknowns here. Second part here now, right? We're multiplying this time, right? So what we can do, we can say row by column, right? And that's going to give me -10. So row by column, we'll say 5e minus 3c, right, is equal to -10. So that's one equation that I have here, right? We can also say, let's work out this row by column. This row by this column here, so that's going to be 2a plus 3c, right, is equal to 17, right? Now what we have here, we have a pair of simultaneous equations, right? And what we could do, we can just subtract both of them. Sorry, not subtract. We have to add both of them to eliminate c. So if we add both of them, you're going to get 7a is equal to 17 minus 10 is 7. So therefore a is equal to 7 over 7. So therefore a is equal to 1, right? So a is 1. So what we can do, we can use that now to find c. Could plug it into any one of the equations. If I plug it into the second one, it'll be 2 by 1 plus 3c is 17, right? So 3c is 17 minus 2. 3c is 15, right? And c is 15 over 3. So c is 5, right? So that takes me to the end of the January 2025 paper 2, right? I hope that you all are okay with the solutions. Please remember to hit like and subscribe for me, please, right? Please remember to hit like and subscribe. And like I said before, right, my exam preparation for chemistry, physics, and add maths have begun for the May 2025 exam. All right? Take care, guys.